Hello, everyone, and welcome to the Ask the Expert webinar, Product Build Deep Dive, Payment Integrity for Procurement via Solution Factory. My name is Thiago de Souza, and I will serve as your moderator for today's event. Now I would like to take a moment to introduce our presenters. First is Kieran Parabia, a Payment Integrity for Procurement Product Manager here at SAS. Kieran drives the strategic vision behind SAS Payment Integrity for Procurement, a product designed to modernize fraud, waste, and abuse detection through simplicity, scalability, and intelligence. Also on the call is Nicholas Ablett, a Senior Manager of Government Solutions and R&D. Nicholas leads a team focused on developing solutions for government fraud, waste, and abuse. He conceived and led the development of the Solution Factory tooling, which has contributed to significant success for SAS customers and is used in numerous solution domains.
Covering the Solution Factory, details of what it is and how it works, and before then showing how that's used to generate the procure-to-pay solution. So I'll be taking you through the Solution Factory, and then Kieran will be taking you through how that's used to create the procure-to-pay solution. And then we'll have questions at the end. So to start with, what is the Solution Factory? So the overall goal of the Solution Factory is to improve the competitiveness and quality of SaaS software products for solving customers' business problems through facilitating low-code, no-code production, deployment, and modification of solutions on the SaaS Via platform. The basic principle is that the end-to-end solution is configured by a single solution configuration file. What the Solution Factory does is then take that configuration file and transform that into different components of your solution, whether that's data management or whether it's configuration of the products that you'll be using as part of the solution. So what it's essentially doing is integrating those products into an end-to-end. It's following best practices that have been laid out by our experts, experience working with different customers, as well as experience of different members of SAS. And what it produces is open, comprehensible, and modifiable sets of code. As you can see, the intention of the Solution Factory is to be used by different teams for different exercises. So what we'll be showing you today is how within R&D we've been using it to generate a solution. But we also have different partners, whether it's SAS professional services, our partner delivery teams, or even customers themselves who have been using the Solution Factory to generate solutions to solve their problems. At the heart of it is automation, right? So what we're doing is taking the solution configuration file, which is written in a way that's very readable, version controllable, really is trying to capture what data you're using, how and where you're using that data, transforming that into the actual individual steps that process that data. So if you say you want to load a table, there's multiple steps involved. It's converting from one to the other. And what does that change? So whenever you're building a solution using the SAS platform, there's quite a lot of development work that happens from the design of how you're going to do technical integration. So how are you going to incorporate your decisions and your models into your overall data? Where is that data coming from? How is it getting into the system? You have to do that integration design. You have to prototype the integration. You have to test the prototype. And you then have to repeat that to complete out your solution. And then as you iterate on what that solution does, you're then repeating a lot of that exercise as you go along. And try and take that and turn it into, what is it the problem we're trying to solve? And what's the problem we're trying to solve? Understanding the data and working with the data, because really to get to the bottom of a good solution, we need to make sure we understand the data. That's critical. And then being able to iterate quickly on that solution design to solve the actual problem and get the value out of the system that's being built. So a brief solution overview. So at the heart of a lot of the solutions that we build in this space is Visual Investigator. Visual Investigator out of the box, once it's installed, it's kind of a shell of a product, right? It needs data to come to life, right? And to have data, it needs your solution data model. So the first stage is loading that data, making that data available to Visual Investigator. Once you've loaded that data into your source entities, so whether that's external data sources, or it could be that you just set up internal entities within Visual Investigator so that user data can be captured within the system. You then have a searchable system It might be you have some relationships so you can navigate that data, but you're still not at your complete set, right? We're not getting a lot of value out of the analytics of the SAS platform. The next step is to do entity resolution, network generation. So we're looking at taking that source data and taking data that might be internal to your organization or external, and being able to find out where that data matches. So being able to identify people, addresses, IP addresses, etc. within your data, and create those as resolved entities and create relationships then within your data between the events that have happened in your source data and the things that were involved in them. Once we've done the entity resolution, we then have within Visual Investigator resolved entities, relationships, and networks, which are sets of data that are connected and are useful for identifying things like organized activity. The final step is now we have all of this rich data, both the original source data as well as derived information that has come from the entity resolution. We're able to make use of all of that data and the data model that is a network-based data model in our decisioning. So defining what inputs we want to those decisions so that we can then create our rule sets, create our models, and deploy them operationally into a system that runs end-to-end, takes that data, creates our scenarios, creates our overall scores against entities, and then is able to send those as alerts to Visual Investigator via the API that Visual Investigator provides. For those 3 stages, we have 3 components: data load VI batch, R10 VI batch, intelligent decisioning VI batch. We're going to be focusing on the batch side of the system during this presentation. We do have real-time variants as well, but we're going to be focusing on batch in the use case of procurement. So start off, data load VI batch. What is it? What does it do? So just to try and explain this diagram a little bit, we've got different things going on here, right? We've got the source data that is typically held in existing systems, right? So in the case of procurement, that might be something like Oracle or SAP, for instance. We need to get that data into the actual runtime environment where Visual Investigator can make use of it, where our analytics can make use of it. We also have a development environment. So during the development stages, there's some activities that are happening that aren't happening during runtime. So during the solution development, we have our solution developer interacting with the solution factory, modifying the solution configuration, and from that generating certain steps that would happen as part of solution. So that's the incremental ingestion of the data. That's the DDL for the tables that we actually want to deploy to. And also be able to configure different ways of loading data. So what do you want to do with historic versions as we get updates over time? Doing some sort of data validation on the data as it comes in, and the interaction with Visual Investigator to actually make sure that the search index is maintained and kept up to date within Visual Investigator as the data changes over time. So as an end-to-end, as a rough guide, we've got the source data that's going to be coming into the system. That's going to be extracted from that system and either inserted directly into the database staging table that's set up by the solution factory, or it can go via JSON message, for instance. So we have a way of reading in JSON messages, mapping those to our staging area and loading that into the database. From there, we do validation. Records that are invalid are moved to the error table. Records that are valid are moved to our actual table that's going to be presented to Visual Investigator and used for our analytics. And historic records are then moved to our history table where appropriate. The next stage is our entity resolution, so R10 VI batch. Again, we've got the development environment where the solution developers actually modifying the configuration, and then in the runtime, that generated solution code runs alongside the static R10 VI batch code to perform entity resolution and to save the output back for Visual Investigator. And again, that handles full incremental processing. So as new records come in, they get sent through entity resolution, and the output is incrementally updated. It also makes sure that the ID used for those resolved entities, so person 7 stays as person 7. It runs a batch cycle. It includes error checking. It can be run as an incremental batch, so very small batches. You could run it every 5 minutes and process data as it comes in, or if data arrives daily, for instance, that could be much larger batches. It's the same code end to end, and it's optimized for performance from end to end. Again, high level, what the process that's actually happening is we've got our source entities that we've loaded using data load. What the configuration of the solution factory does is select the fields that you've mapped to be used in entity resolution from those database tables. It applies parsing, cleansing, standardization to that data in a consistent manner across the different data sources. Constructs the input to the actual CAS action that's going to be doing our entity resolution. Now, Artane itself is a set of CAS actions that's available as part of the VIA platform that very efficiently scales horizontally and can process large volumes of data through entity resolution in an incremental manner. So, for example, we have customers that are putting billions of records through this sort of system. We then take the output of that entity resolution, transform it and combine it with the input data to construct our final tables that are available, again, for both analytics, but also for visual investigators. So how do we represent that resolved entity when it comes to the users within Visual Investigator? The final stage of the process is intelligent decisioning VI batch. Now, there's a lot going on in decisioning, so obviously I'm not going to go into detail through all of the decisioning capability, but mainly talk about how we integrate the data into the decision. I think Kieran will be showing an element of intelligent decisioning itself in the demo. Now we have this extra persona. We have our scoring analyst. So we have a person who's actually creating the rule sets, creating the models, testing the rule sets and the models. So we have our solution developer setting up the flow, so determining what the actual source data is for that decision, and configuring how the output is going to be used. So is the output going to be used, for instance, to create alerts within Visual Investigator? So they're setting up the solution, doing the configuration, which is generating the runtime code for decision input and decision post-processing. And then our scoring analyst is taking that input data and creating the decision, which are our rule sets, our models, etc. So that when we deploy that operationally, we then get an end-to-end run from the selection of the data, creation of the input, execution of our decision for intelligent decisioning, and then post-processing the output, saving the output to the database, and sending alerts where appropriate to Visual Investigator. At the heart of it, intelligent decisioning as a tool scores entity by entity. So if you're scoring invoices, its expectation as an input is that there is one row per invoice going in. Now, obviously, we've got a network data model. So we've got, for an invoice, there might be a supplier, right? And that we might have a person associated with that, for instance. So what intelligent decisioning VI batch does in the solution factory, it allows you to use that network data model and construct an input that's appropriate for the decisioning process. So that's taking data that's both at the level of the decision and other entities that are at different levels, and then applying transformations to those, whether we're aggregating that data or whether we're turning it into a data grid, which essentially gives us a one-to-many relationship. It allows us to say, for a supplier, I want to see all the invoices and I want to be able to reference those invoices in my decision. So each of our decisions have this sort of construct. The output then is scenario-fied events, and we can create multiple decisions where one decision feeds another. So the end-to-end flow then, we have the source data, which are our VI entities, whether they're source data or whether that's resolved entities, and also the relationships between them get used. We then have some additional steps that happen in database. We have entity profiles, so they're aggregations that happen at the entity level that are calculated, persisted, and maintained in the database, again, incrementally. So every time the batch runs, it identifies what data has changed, what needs recalculating, and updates that data so that you have a consistent set of information about each entity. And we have population statistics, where we're looking across our whole population and, for instance, working out what's the normal invoice amount for a product of this type. Yeah. Both of those can also be selected as inputs to our decision. So we can pick from the source data aggregations we've done about the entities, as well as aggregations we've done about the whole population or a subclass of the population, so a peer group. That then goes through intelligent decisioning. So for batch execution, that's executing in CAS. The output then is persisted to the database in the post-processing code. So each of the scenarios that are fired, whether it's included in an alert or not, gets saved to the database. So we have a complete set of scenario fired events available. And where we've got a flow that we want to actually raise alerts for, and we've got an overall score assigned to that entity, that's also saved to the database. And then where the threshold is reached, those scored entities are sent to Visual Investigator as alerts. So what are the actual solution artifacts then? What does a solution look like? So I've mentioned that we have a solution configuration and then we generate a lot of code. What it comes down to then is that a solution is essentially made up of a few artifacts. We have our solution factory configuration, which then allows us to generate all of the actual end-to-end code. That includes the source entity data model, how it's received and loaded into the Visual Investigator external database. We then that also includes which data is used to form which entities and how, and what data is then provided to the objects created within Visual Investigator. So when we look at a resolved person, what information do we want to see about that person? That also defines the flows that run against which entities, and then what data we want available to those flows. So we're scoring a supplier, but we want information about their invoices, for instance, or we're scoring an invoice and we want information about other invoices from the same supplier. And which flows raise alerts within Visual Investigator, and which maybe are there just to create scenario-fired events. We also have the intelligent decisioning flows and rule sets. So the solution factory configuration doesn't replace that; it augments that, right? So intelligent decisioning already has a user interface for carrying out your rule creation, model development, and deployment, maintenance of that. So that's still an important part of the solution created with the solution factory. And then obviously on top of that, your Visual Investigator configuration. So the solution factory does generate a configuration for Visual Investigator, but there's a lot more enhancement you can do to that using the admin screens within Visual Investigator. So all of the configuration of intelligent decisioning and Visual Investigator is done through administration screens, not through going around changing XML files or anything like that. Within Visual Investigator, you might be doing things like updating the pages and the look and feel. You might also be adding things like workflows. For the solution factory, we have a configuration user interface. Behind the scenes, we have a JSON configuration file, which can itself be version controlled and is ordered and simplified in a way that it's quite easy to understand within versioning what's changed. But the user interface essentially allows you to edit that file, so be able to modify your solution configuration. So it's essentially a enhanced JSON editor that allows you to do things like look up values from drop downs, validate that things correspond, and provide you a more user-friendly way of configuring that JSON file. So what skills are needed for the solution factory? So the most important thing is what the solution factory doesn't do is replace business domain understanding, data management knowledge, analytical skills. It doesn't solve your problem. But what it does do for someone that understands the problem and has an idea of how they want to solve it, what it does do is make it easier for them to do that. Spend less time worrying about systems integration, data integration, more time about what are the techniques I want to use to solve the problem I've got. Yeah, it's configured via JSON, but as I say, there's a user interface for doing that configuration. Minimal coding is required, but for any sort of debugging or extending or augmenting, obviously base SAS skills are useful, as well as we use a lot of SQL. So understanding what the solution does, seeing the code that's generated, a lot of that's in SQL. Understanding your platform, understanding CAS obviously is beneficial too. You don't necessarily need to actually do any coding in any of those languages though to create and run your solution. We also then do have training available for Visual Investigator. There is training available for, there's some for R10, it's a bit limited, but we also do have training available for intelligent decisioning. And we can provide enablement for the solution factory. The documentation for the solution factory takes you from, step one through to creating a solution. So the training maybe isn't always required to get people up and running, but we can provide that enablement if required. Okay, so that's a very quick run through of the solution factory. I appreciate that was very high level. There's lots of details, so there'll be time for questions later. But what I'm going to do now is not quite hang over to Kieran. Well, Kieran, you talk us through this slide, I think.
Yeah. Thank you, Nick. Thank you for this good overview about the automation process for the solution factory. Now, we would spend some time on exploring this concept and bringing these concepts to life while we develop our SAS Payment Integrity for Procurement solution. Everything that Nick mentioned in terms of concepts is exactly what we have used in building our product and the product configuration. So what we are going to do is we're directly going to jump on to the product and see how each of these concepts come to life. We are going to put on the solution developer head today and try to build this product in next 30 minutes or so that we have for this webinar. What you see on your screen now is the SAS Visual Investigator user interface. This is where all the investigation, alert, triage happens for our product. This is a fully configured user interface that's made available to our customers and investigators. Today is not about going into the detail of how to perform investigation using the SAS Payment Integrity for Procurement product, but rather how to build it using the solution factory and how each and every component is going to feed into the user experience that we plan to offer. Nick did mention a lot about automation, and that is the heart of the product development here. Solution factory, the key component that would help us automate this entire process. We would focus on describing and detailing out the business details of the product, and solution factory would take care of creating all the related runtime components and all the related batch and operationalization process that we need for the product to perform the task that it is meant to. Now, there are various aspects to the automation on solution factory. So one of the key artifact that we would be dealing today with our solution developer hat on is the solution factory user interface. We would develop the payment integrity for procurement solution factory configuration that would encompass all the details all the business detail that we need for the product to work. Here is an example of the file, of what the file looks like. Okay. Instead of going into the detail of the JSON, we would directly jump onto the user interface and try to explore how we are going to build this product here. Okay. So the first step, as described in the overall build process, is defining the source entities. Source entities would be the one that would encompass and incorporate all of the customer data that's needed for detecting fraud, error, waste, and abuse for procure to pay use case of SAS Payment Integrity for procurement product. The configuration gives you a nice user access here where you can start by creating your own entities for the purpose of your product development. What we are going to do is we are going to use one of the existing entities that we have created in the product and try to get a sense, an idea of how this would extend to building all the other entities. So we'll start by defining the employee entity. Now, the key data elements that go into identifying procurement, fraud, waste, and abuse are the HR master data, the vendor master data, or the supplier information that registered within the system, and finally, all the transactions, financial transactions, as well as the material management transaction that help capture the entire life cycle of procure to pay. On the left side of the screen, you can see all of these elements pre-configured and developed. Let's jump into developing one of the entities, employee. When we start by creating a new entity, we have an option or defining the name for the entity. We try to keep this as real life and as close to what the users on Intelligent Visual Investigator are going to reference this to. It would give you an option of providing the name of the actual database table that's going to hold all of this information. Solution Factory and the product will also provide you a set of file later on in the process where you can define the actual connections to the database. When we define the entity, you will have an option of defining what are the various load types that we want to be performed on this entity. Is this entity going to be a full refresh every day and no history needs to be prepared? Then you're going to select the no history option. If you want the system to read the ongoing data that's received every batch and prepare the system history, then you're going to select the maintain system history option. If you want to rely on the source system to provide us the entire amendments and the history for the employee records, then we are going to select this option. Now, what this does is each option that we select here is going to trigger a specific template within the Solution Factory and would generate the relevant runtime code that helps us achieve that particular task. So the more you explore the configuration, you'll see some of the entities use the source history table and some of the entities would be a full refresh depending upon the business requirement that is created. Now, it also gives you an option of retention of the data. Again, these are a lot more technical details. It helps you configure. What do you want to do with this data, this entity over the period of time when the project is in the implementation phase? Then, once the basic information around the entity is generated, then we go into the next phase of defining what that actual entity looks like. What are the different columns that are going to define this entity, which would capture the business essence, as well as it would help the investigator in terms of visualizing the entity, as well as would help us author the business scenarios that would help us find the fraud, waste, and abuse for our product. We start by defining the first column, which is employee party ID. Employee party ID here represents the primary key for the table. There are various options that you can select that would help us give some constraints or validation required for each of these entity columns. In this case, employee party ID is a primary key. If there was a not null constraint that you want to put or a unique constraint you want to put, you can checkbox the relevant information here. Again, depending upon what checkbox you select, the corresponding template on Solution Factory would be triggered and the respective code that helps us achieve that task would be created. While defining the entity, you'll have an option of defining the data type. Here you can see the data types are very native and close to Visual Investigator, because in which Visual Investigator becomes the backbone of what we are trying to build here. Out of the box, Solution Factory is going to support 3 databases: Oracle, SQL Server, and Postgres. Here, the data types are very generic in nature, and there would be Solution Factory templates behind the scene that would help what a string database means in terms of Oracle, and what it means in terms of Postgres, and what it means in terms of SQL Server. Now, you can keep on continuing this process and start defining each and every column that helps you identify the entity in its entirety. The data model that we are going to use is again very native to Visual Investigator, which is hierarchical in nature. So if there is additional information around the entity that you want to create, you are going to create more child entities here. So this would help us create the child entities. This is more to say that if employee has more email IDs or various addresses that are recorded in the system, then we would present this information to Visual Investigator as a child entity. The options of setting up the child entity are very similar to what you saw at the entity level. Again, helping you identify the name of the entity, which database table it refers to in the background, what are the historical load types you want to use. The historical load type represent the slowly changing dimension, SCD type 1, SCD type 2, etc. And it will help you then identify and define the columns specific to the particular child entity. Repeating this process, you would have a complete employee entity and various childs for the employee entity. Okay? The process would then, and from the Visual Investigator perspective, we would look at having a current table that represents all the latest information about an employee, and that would be represented by the employee entity. We also provide an option here which helps you retain all the history or amendments to the history. In this case, an employee version table or an employee history table would be presented. This is extremely useful when we move to the next step of generating the net entity resolution and networks, and also in scoring in some essence. Similarly, you'll see various other entities that have been developed: supplier, the parent supplier entity using the same concept, and then the child of the supplier, and invoice entity. Now, what we have done is we have finished our first half of the work, which is defining for our use case, what does the data model look like? And then now we complete this by defining various relationships with our source entity. So if we have defined an invoice entity, then how does the invoice entity link to the supplier? For this, we would provide the relationship entity information here. We are going to say, this is a relationship that links invoice to a supplier, pretty straightforward. Which database table does it represent in an external data store? Here, there would be a query option that helps you very conveniently select which entity from our previous definition is the from entity and which entity from our previous definition is going to be linked to this. Again, there would be an historical data type load option and the retention option. When we start defining the columns for this would again fall into the very natural data modeling perspective. We would have the primary key for both of the entities, from entity and to entity, which is what is related according to this relationship. And there can be more attributes around what is the role of this particular relationship. Are there any change begin dates, last updated date, and all the other information that you want for the relationship would be configured here. Since the product is fully configured, here you can see there are list of relationships that we have created, which links employee to all of the transactions, supplier to all of the transactions, and also link each transaction of the procure to pay lifecycle with each other, like purchase orders, payments, invoicing, good receipts note, etc. Now we have done our first task of defining the data model for our product. Remember, Solution Factory is absolutely modular in nature. That means now we are ready to build our product. We would feed this information on to the Solution Factory configuration. So remember, Solution Factory, the whole automation process, had transformations and also had templates that were predefined. We feed the business knowledge in terms of the PIP SF configuration.json file and run the Solution Factory code. When we run the Solution Factory code, it is going to create the runtime code, which is specific to whatever is included in the configuration. At the moment, we have included data load section, and hence it has created all the relevant artifacts and the runtime code for data load. What does this include? This includes the DDL script that's going to help us create the tables that we have defined on database. As mentioned, it supports 3 databases out of the box: Oracle, Postgres, and SQL Server. And there would be various database scripts that would be created, which when ran on database is going to create all the relevant tables. Apart from this, it would also create every single thing that we have defined about how to load this entity and present it on Visual Investigator. So we were working on an employee entity, and this is the code that the Solution Factory has created for us. What does this code do? This code connects to the external database, transforms the data using the definitions that we have created. It also would incorporate the historical changes or type 2 data loading or type 1 data loading that we have defined on the configuration, and make this data available on Visual Investigator. All of this is automated and generated. Okay, none of this code is written by the solution developer that we are at the moment. And once the runtime code is generated, we still need to operationalize this. To operationalize this, the Solution Factory would provide you with the data load VI batch process. This process would help you wrap the entire runtime code together and help you create an executable that would help run the entire batch processes in the configured time, date, and whatever frequency we need to achieve them. Now, we put on the solution developer hat. We configured our data load VI section. We configured the relationship. We fed the information back to Solution Factory and generated our runtime code. Assuming the data load VI batch works perfectly fine, we have now loaded our first entities on Visual Investigator. Let's go and see how this entities looks on Visual Investigator. I'm going to search. I'm just going to do a blind search here and try to find every single thing that's available on Visual Investigator. Here is the employee that we have been configuring. And these are all the employee information that are available as a part of the Visual Investigator search. When I jump into one of the employees, Bob, we would see all the employee information that we had configured on Visual Investigator, on the Solution Factory configuration is available here. The party name, the party numbers, the tax codes, etc. Interestingly, if we go down, we would also see all the related information or the child information that we had put. The addresses, accounts, mobile number, emails, telephone, etc. This one part here completes the entire generation of the data load section of the payment integrity for procurement using Solution Factory. Fantastic. If you are comfortable with this, we move into the next phase of utilizing this information and generating the resolving entities and generating the network. That is where we jump onto the next section here and now start identifying which data elements or which designed data items are now going to fit into our entity resolution process. The payment integrity for procurement, key high-level data elements are vendor master or the supplier information, HR master or the employee records, and the transactions. Transactions are not so useful from entity resolution perspective of procurement, so we are going to exclude them. But we are going to keep our focus on the employee and the supplier data that we have defined. And also, there is a third-party data ingestion, which would be related to a company house or anything that provides us the entity enrichment data. Now, what do? We inform the R10 VI batch, R10 section of the Solution Factory that we are going to use the source and we are going to create an entity employee, which is going to use the following tables from the input: the employee, employee email, employee address, employee mobile. So basically the entire employee with all of the child. Similarly, supplier and all the other information. Now we are going to consume this information to generate the resolved entities. And that's where we naturally progress into the next phase of the implementation, where we define what do we get out of the source data that we are presenting. So when we present the employee information, we are expecting the product to provide us with a resolved person entity. This is where we would combine all the instances of the employee record and the third-party record and identify all of this record represent this one person. This is again going to be used for enrichment of our alert and scoring processes going forward, and also it would be used for visualization. Now, when we define what a resolved entity looks like, there are three key areas that we have to configure and let the Solution Factory know. One of them is, what are the elements? The elements are the raw data information that links to the person. In this case, I'm defining a person number. You can think of it as an employee number or an employee ID or any identifier that is available within the source data. I'm also going to say from the employee table, identify and find the party number for me as a person number. There is a section that Solution Factory would provide where you can use data quality cleansing options. This would help you clean, enrich, and pass the information so that it could be used in the most efficient way on R10 entity resolution process. We'll keep on defining and identifying each of the useful elements from our raw data that is going to help us with the entity resolution process. The key idea here would be some of these elements on their own would be so strong that they would be able to identify the resolved person, like for example, somebody's tax number or somebody's social security number. And some of the elements would be combined together to give us a good sense of what that resolved person looks like. This is the section on the compounds where we combine each of these elements together or few of these elements together to get some meaningful compounds which would define our entity. Example of that would be we would define name and address. So if we have first name, last name, and an address of a person matching, then we are in a reasonable range of saying possibly that is the same person, and we should create the same one single entity for all the records that are referenced for this particular name, last name, and address. Now, jumping into, once we are able to create all the relevant elements and combine them together in compounds and get a resolved person, third part of configuring that entity resolution process is where we do not lose the track of where this information came from. And hence we create and populate the reference field. Reference field would help create a child for the resolved entity and preserve all the information that is available on the source data. So if a resolved person 1, 2, 3 or Bob was created using 5 records from our HR data as well as from our external party information, all of those 5 source record would be referenced, would be saved here as a reference data. This would help us class cover information thoroughly and give us an audit of what we are creating as well. Now, We have done a lot of work here in such a small time and created, identified the source entities that are going to feed into our entity resolution process, also designed what it is going to create as a resolved person to enrich our detection. And then we are going to jump into creating the relationship with the actual source data of the newly created resolved entities. Like, for example, linking the employee record to the person entity, or we are going to make it as complex as creating relationship between the resolved entities themselves, like person to the resolved account or a person to the resolved location. This all information is enough for us to now trigger the build of our RTENG solution factory code. Additional information that you can also provide is how do you want to soft delete and tune your networks? Can we trim all of the links that are identified in the system correctly together and make a relevant network that's very useful from fraud, error, waste, abuse detection for procurement? All of those information would be populated here. People familiar with the entity resolution process should very quickly easily able to identify what all of these things mean. Now, as a solution developer, we have done and completed our second task of configuring the entity resolution process. We feed the newly updated JSON file to solution factory here, and now run the solution factory code. Once we run the solution factory code, the runtime code related to data load as well as RTENG is created. What do you get in the RTENG code? You get the DDLs that are specific to all the tables related to RTENG process. You will get the scripts that is going to create how the input for the RTENG cast action for this purpose looks like. And most importantly, it would also create what the output storage and persistence of the data would look like. Once you get the resolved entity, which table in the output and where they are going to be fed. It would also create you the updated Visual Investigator configuration so that now, once you run this process and go on Visual Investigator, you would have not just the source entities that you have defined, but now you would have all of the resolved entities as well. So going back to our search functionality, and now we see that not just employee, we also have the person entity here. And this here are all the people, these are all the people who have been resolved using the source entities that we have defined in our entity resolution process. Let's have a look at the one of the resolved entity, Mr. Benjamin Dawson. Everything that we define at the output for the entity is what you would be able to see here. You would be able to see the first name, middle name, and all the relevant information. And based on the relationships that we have defined at the bottom, second half of the screen, you would be able to see all the relationships and what other entities that are related to our newly created Benjamin Dawson entity. And the person references would now point you back to all the instances of the person record that were found in the source entity. Here, there are two records that will merge together to form the single entity. Now, all the information in the text format is still fine, but the key idea is to explore the network and the relationship. So we are directly going to jump into the network view and see how this entity is created. So if I go into the workspace, and here I can see that there is an entity, Mr. Benjamin Dawson. And when we select the source entities, which employee records, you can very clearly see here that this particular record for Benjamin Dawson and the other record for the Benjamin Dawson have been clubbed together to form the newly created person. Now we can utilize this instance of the resolved entity and write our various rules to identify and combine the risk that is happening at each individual occurrences of the Benjamin Dawson from the source. Fantastic. Now we have finished two key aspects of our solution development and seen the result. Now we are going to finalize the development of our product by utilizing all of the information and jumping into the last part of the product development, which is let's score the available data and create the alerts. Now, so far, what do we have? We have the source entities. We have enriched them by running them through the entity resolution process, and we have now the resolved entities. Maybe these two are not enough for us to start writing the best possible rules to identify our solution. So we gave you the option of defining the profiles. Okay, here you can merge your entities and transactions together, create the automated profiles. As you can see here, we have created various profiles here at the supplier level. So one of the profile that would be very useful in our rule authoring is the supplier invoice profile. This is where we are trying to identify month-on-month behavior, pre-identify the month-on-month behavior of the supplier's invoicing pattern. And this would be stored in the database so that either we can use this for visualization or in some of our reports or in rule authoring, where we are trying to see the supplier's trend of invoicing compared to the historical. Okay. Once we select and populate and identify the profiles, we'll also have an option of providing the population statistics. There are various benefits of creating the population statistics, and in our product, we're not using that at the moment, but very soon we will be looking to add more statistics here that would help us enhance our score. Now, once all of this data is available, we would start defining what does a flow from intelligent decisioning perspective look like. So I'll take an example of a flow, which would be, let's try to identify all of the unusual behavior of a supplier using their invoice trend. So is the supplier suddenly invoicing 30% more than all the averages they have been doing previously? Or if the supplier is particularly invoicing a category of an invoice compared to what they were doing previously. Now, what do we need? How do we define this here? So we need to go into the flow section, select the new flow, and give the name to our flow. Okay, the name to our flow should match exactly with what we are going to later on design on intelligent decisioning. At what level the flow is? The flow is at the supplier level. That means every single anomaly that would be detected here would be attributed to the supplier. What do we need when we want to author our rules on intelligent decisioning? We need lots of information around the supplier. Do we want to exclude certain type of suppliers because they have a certain party code? Do we want to exclude certain suppliers which have an inactive status code? Hence, we would select the list of columns that we think are necessary from the supplier table for our rule authoring. Now, remember, the flow that we are creating is identifying the unusual supplier behavior from invoicing perspective. So we are going to define one more input, which is going to get all the invoices or the invoices specific to a particular supplier, which is necessary for trend analysis, as a data grid. Again, it is an assumption that people know what a data grid is, where we was going to combine one-to-many relationship into a single column. So we'll create a new column, invoice data grid column. Solution Factory would help you define in the following way. We are going to say the flow is at a supplier level, but this particular input is at an invoice level. What is the type of input that we are selecting? It is a data grid input. Is there an additional filter that we want to put and exclude the data, which may not be necessary from our scoring perspective? And then we would select what are the columns that would go into defining and building our rule. So these are the list of columns that would form part of our intelligent decisioning input. Perfect, we have defined everything. Now here, lots of design decisions would come into play. We would design the flows from the perspective of identifying and addressing a certain area from the fraud detection perspective for a procure to pay. And depending upon that, we would then classify how many business scenarios is this area going to need, 10, 50. And based on that, we are going to upfront define the entire input universe that would help us write all of these 10 or 15 rules that have been selected for supplier unusual invoice trend. Okay, now we have defined our intelligent decisioning section. We would keep on going and perform similar action for various inputs. Solution Factory would also help you identify if some of the inputs generate a score and also an alert. But maybe we will touch upon that later on. Now we repeat the same process. We give our updated Solution Factory configuration to Solution Factory automation process, run the Solution Factory code, and this time we regenerate the procure to pay runtime code for the entire product. This includes the data load section, the RTank section, and intelligent decisioning section. Remember, what do we get when we run the intelligent decision section of Solution Factory? We get all the DDLs specific to the database tables that are needed to help support our scoring implementation. We get the definitions and the code related to how the input that we have defined would be created. Each of the flows that you see here have corresponding inputs that are being created. Okay, and then it also gives you the post-processing. That is, once these inputs are created and business scenarios are authored on it, what do we do with the output? We take the output, convert it into a specific structure that's then going to be used by visual investigator for addressing the alerts and also providing the contextual information. All of this runtime code is generated using Solution Factory based on the definition that we gave on the JSON file. Again, or like all the other components, this intelligent decisioning section will also be combined with the intelligent decisioning VI batch process, which is basically the wrapping and operationalizing or productionalizing the runtime code that we have just created. This now finishes the end-to-end build of the product using Solution Factory, or from the solution developer's perspective. Now, the only last thing left is the work that needs to be done by the scoring analyst or the analyst. So we now jump on intelligent decisioning and utilize all of the inputs that we have created and create the corresponding flows that are going to help us identify the anomalies. Our standard offering provides you with 16 decision flows and certain roll-ups and scoring flows that help us complete the entire fraud detection story for procure to pay. Let's jump on one of the flows here. So this is another flow where we are trying to identify unusual transactions or unusual behavior on an invoice transaction. We all sit together as a developer and identify the business scenarios that are going to be catered. And so we define the input data structure. Once the input data structure comes in, then we start authoring the rule on intelligent decisioning. Now, let's take an example of one of the rule here. Okay, so this is where we are trying to flag invoices which have been invoiced on a Sunday. We don't really expect this from our procurement, from our procure to pay lifecycle, but if it has happened, we are going to flag them together. So here you can see a very simplistic flow of defining the scenario ID for this particular scenario, because each scenario is going to be uniquely identified using the ID that we create. We are going to have some sort of a business logic here that is going to identify based on the create date when this invoice was created. And if this date falls on a weekday number 1, which represent a Sunday, then we are going to flag this. Now, when we flag this, what do we mean? We create a column which is the restriction, or which is what is needed by the Solution Factory to understand that the output is actually a scenario fired event for this particular scenario. The structure of the output should be scenario ID underscore message column. What is this going to say? This is going to say that the invoice with an invoice number this on a particular date is a Sunday. And similarly, this is then going to be processed as an additional scenario, and the Solution Factory would take care of how this is going to be stored, persisted, and then sent on visual investigator. You also have an option of providing any optional enhancement values to the scenarios, which is the value, how much does this scenario fire event values from investigator perspective. Do we want to give any specific score here? We can always prioritize between 0 and 1 and give 0.6 because we think this is more valuable than any other scenario fired event. And if there is any other contributing objects or any enrichment or associated information that you want to pass along with this scenario fired event. In this case, we are going to send the invoice itself. So when somebody looks at this scenario fired event on Visual Investigator, they see the message and also the invoice on which it is flagged. Now, when our scoring score developer or score analyst finishes designing of the intelligent decisioning flows and rules, they publish it using the same name that we have defined on the flow, and then it would be used and sent in an automated way for post-processing. Now, as a solution developer or a score analyst, what have we done so far? We have defined the business need on the data side. We have resolved the entities based on our understanding of the data. And then we have designed the flows and rule sets that are going to help us address and identify the fraud action. What we have not done is we have not at all been worried about how the integration of all of these processes is going to happen in the backend. That is the job of Solution Factory. So Thiago, this is all we want to cover today. We work on the business aspect of defining the solution configuration, and Solution Factory takes care of creating the runtime code as well as the operationalization code to help us achieve the product development.
Thank you. I don't think we have any time for Q&A today, but any unanswered questions we have, we will answer in our follow-up communities post. On behalf of myself, Nicholas, and Kieran, and all of SAS, we really hope that you enjoyed today's webinar. Thank you all, and have a great rest of your day.